Okay, we are live. So basically, I have some problems that I think cover the old material that you guys can do. This one is with related rates. So, or not related rates, percent change. How was the percent change problem on the exam?
Do we have? Yeah, I didn't do it.
You didn't do it? Yeah.
Let's get that. See, I knew how to do it. It's just like after I take the test, I'm just like, I can't remember.
With percent change again, it's always like the simplifying step where if it doesn't work out, you're screwed and you never know what's going on. So I'm gonna do one with a box. Okay, that's a box. We'll call this height, and these are spaces. So it's a rectangular box. The height is different. So the formula for the volume is what?
Area was.
No, this is just a box.
Well, remember the one from the test now.
Okay.
It's like area equals 3L to the 4/3. What's the formula they gave us? Yeah, divided. It was like 8 to 7.9. Just the change.
I have no idea.
That was the question. Oh, wait a minute. That was, yeah.
What shape was it?
They didn't give us. Yeah, it wasn't shape.
Okay, they just gave you a formula?
Yeah.
Okay.
You take the derivative of that, and then it's like to change, like delta F would be 0.1.
And find a change in O or something.
Yeah.
Okay. So this one, since they do, like I do a box there, so it's a bit easier. Because the volume is just V squared times H. And if I say that the base is okay, so this is asking about percent change in volume. So how is the volume changing relative to the base and the height? So the base, say, is decreasing by 1%, and the height is
decreasing.
Yeah. So then it'd be negative or positive
For the height.
For the base. If it's decreasing.
That's gonna be negative.
Yeah. So, and we'll say that the height is increasing by 3%. So then we wouldn't just do B over H. We do dB over B and dH over H. Right? You guys, I'm sure, understand all that. Looking at this, what's the first step? So what would it be?
dB equals 2B dB.
You understand how that works?
Yeah, we have to multiply by H.
Yeah, and then we multiply by H. But it's important to remember it's 2B, then times dB times H. Because this is the chain rule for taking the derivative of B. With yeah.
Well, why would that matter though?
So it's like taking a derivative of y. You need to multiply by y prime. So we need to do that with B, and then we multiply by H. And then we add B squared, and then the derivative of just H is H prime, so we'll just do DH. Okay. Now what do I do?
You can probably simplify that.
Yeah, but we want to try to get these, right?
Oh yeah.
So what do I do here? We divide by what?
Oh yeah.
The volume. So then we can get, since we're finding the change in volume, if we want dV over the volume. So we just write the equation of volume. But what makes it easier a bit is that since these are two terms, we can write it twice just to make it seem easier. And just make it two different fractions. So this makes it look a bit nicer. So we have the h's cancel. One of the b's cancel, so we get 2 dB over b. On the right side, both the b's cancel, and we're left with dh over h. We are told dB and dh, so it's 2 times -1% plus 3%.
We have to multiply that by like 0.01 instead of a percent.
Oh, I mean, it's the same thing. Yeah. If we had, if I change dh over h to 2, it's increasing by 2%. This would be a 2, 0. That means even though the base is decreasing, the rate at which height is increasing means that the volume is not changing.
For some reason, all the examples that they did, they always converted to decimals and then back to percent.
Yeah, right.
I don't know why that matters.
It doesn't. I could have easily put 0.01, 0.02. You probably should do that, but you guys understand what I mean. I'll do one with, that's not a volume, or that I don't give you the shape of. So then you guys can see how maybe the test one was. So say the area is equal to 3L squared times B. Okay? And we have to find percent change in area when L changed by 3%, B changes by -4%. So the first thing is to just know this is dL over L, and this is dV over B. And if we want, we can even make it a 0.03 and a -0.04. Right? So I have no idea what this is. It may not even be an area. I could just be using the A as a variable, but we're trying to find the percent change of A, which could be area. So we do dA, and what is dA? What is dA? So to take the third.
It's just so it'd be 6L dL over L.
Just dL.
dL.
Yes.
6L
Times B.
plus 3L squared.
Yep. And we're looking for the change, so we have to divide by area. So we divide this by 3L squared B, 3L squared B. So what do we get? The B's cancel out. 3 at the top, we have a 2 dL over L plus dV over B. That was almost exactly the same thing as before. But do you guys see how that worked? It doesn't matter if you're given a shape or not. It's just understanding the chain rule and taking the area and then dividing by the actual formula, because that's the percent change or accuracy or whatever it's asking for, and then you will be given 2 of the 3 variables. Or if you just have 2, you'll be given 1. So again, this is the hardest step for people. All right. Do you guys have any questions on that? Do you have any questions on that?
I think I did it right off the test. It's I can't remember.
That's it.
I finished. I was I finished it right. But it's 8 a.m. Oh yeah, they started like 5 minutes early just because.
Your finals at 8 too.
Really? On Saturday, right?
On a Thursday. Is it on a Saturday? On the syllabus it says a Thursday.
It might be.
But sometimes they change the final date.
I have a final on Saturday. I just don't know which one it is.
I think Chem might be on a Saturday.
It might be.
Because they probably do that so that it doesn't mess with any other final, because they need every single student to take it at the same time.
Why? They do the same exact.
Yeah.
Mobile rights the same test.
For Chem 1 and Chem 2.
So, like, if you study the test, though, would you be fine on Noble's exam?
Yeah, but it's still, you need to know the material and stuff.
Right. But, like, if
yeah.
you could rework his old test, would you be fine?
Yeah. And ask me about that after the session.
Okay.
So let's do a linearization problem. Did you guys get that right? Was that on the exam?
Oh, yeah. Except they didn't do the L of x equals f prime of a plus f of a times x minus a or whatever.
Yeah.
They did the
change in f.
No. Well, yeah, they did do that, but they did the k thing. No, did they?
I don't remember.
What did they do? They did something with linearization.
Okay. Well, let's just do this problem quickly. But say f of x is equal to x over square root of. Let's go with that. Yeah, move this way. When x is 2. So the first thing that you do is you do f prime, right? You guys know how to do that. Then you do f at 2.
Right?
What?
You'd just do the product rule, wouldn't it? You could do.
Yeah, I mean, the easier method would be to do the product. So then, let's just do it then. X plus 1 to the minus 1/2. What would the second part be?
2 over the square root of 3.
What would it be? Negative 1/2. We bring that down.
Oh, you're talking about the second part of the.
Yeah, derivative.
My bad. I thought you were talking about that too.
So then it's x plus 1 to the minus 3/2 times x. Right? Yeah. And then you can simplify that. You do wherever 2 is. And then you get L of x, which is f of 3 plus f prime of, or f of 2, f prime of 2 times x minus 2. You guys good with that? I mean, we covered it. Then the other part, which was new to you guys, was if I asked you guys to approximate to, say, 29 over square root of 3.9. So 2.9 over square root of 3.9. What would x be in this? If I asked you to approximate to that. So you have 2.9 over the square root of 3.9.
What would x be?
Yeah. You compare it directly to this form.
3.9.
2.9. Because you have x on top, you have x on top,
Okay.
and then you can make sure that the bottom works too. It's x plus 1, so 3.9 minus 1 is 2.9.
Okay.
So the idea of approximation is instead of having to solve this, like 2.9 divided by square root of 3.9, who wants to do that? You can just put in a 2.9 there, and then this answer would be close enough to this answer. So that's why we do approximation. And then linearization is a method. Then you can do Newton's method too.
We didn't have Newton's on the test. Thank God.
Yeah, you might have it for this one then.
He said that he would give us the formula. Though.
Yeah. It's not too bad, but
I hate how he handwrites the exams. I know I sound like I'm complaining a lot, but I know I really do.
we all complain.
Because sometimes you can't read it.
Yeah. Then sometimes you just have to go up and ask.
That's what I do.
Do you guys want me to go over y prime, or are you guys good with that?
I think we're good. With that.
Like cosecant of cosine of function.
Wait, cosecant of cosine.
Like it's like when you try to
Fine.
rule. Yeah. The chain rule.
Yeah.
Y is equal to cosecant of cosine of x squared plus 2.
Yeah.
You
gotta
do the chain
roll
Yeah.
twice.
3 times.
Right? Oh yeah, 3 times. You're right.
Just well, yeah.
Let's do a related rates problem.
I'm usually good. Isn't it related rates?
I got that.
That's good. The thing about related rates is that once you know what each information they give you, it's not hard at all afterwards. But you have to get to that point
You have to be able to take it apart.
Yeah. You have to get to the point where you know what they're giving you, what it means, and what formula to use. And it will be basically like tangent of theta or the Pythagorean theorem for you guys. Unless it's like volume.
What was the one choice? What was the? I think it's Pythagorean theorem. We did have but we had some.
Okay, two planes are flying at 25,000 feet altitude. So just keep that in your mind.
Wait,
So
both of them are flying at sea altitude?
at the same altitude. At a certain instant, airplane A is directly north and is flying 4 miles from a fixed point towards that point. So for this problem, you need to figure out what it looks like first of all. So it tells us that A is flying north. So we'll have A here, and then it's going north towards some fixed point up there.
It's 4 miles to that point.
So this is 4 miles. So it's going directly north. Airplane B is flying directly east and is 3 miles from that point. So east would be this. flying east, and it's 3 miles
From that fixed point, they're going to the fixed point.
from the fixed point, away from
The
it.
distance, not the rate.
Yeah, no, it's going away from the fixed point. That's what.
Yeah, that's what I'm saying.
It's going away from that point.
I thought they were both flying to the same point.
It's relative to this point, they're both flying at the same altitude.
Yeah.
So this is not altitude, this is north and east.
Right.
Like it's plane in 3D. So they ask you to label the diagram, which you should be able to do just by knowing where they're going. Yeah. And when you get a problem with like airplanes and stuff, they're gonna be like right triangles. Like they'll just say north or south. So airplane A is flying 250 miles per hour. So it's 250 miles per hour. Now, if we're relative to this point, is that positive or negative?
Negative. Because you're getting closer.
Yeah.
That's
Closer
true.
down distance.
Yeah. This distance is increasing, so we take the velocity as negative. Airplane B is 300 miles per hour.
If it's going away, it's
Yep.
there you go.
Now, if
That's right.
we had drawn B coming from this side, it would have been negative.
Right.
But that would be us misinterpreting the problem and then getting the wrong answer. So it's always good to understand what the problem is asking. Find the rate of change of the distance between the airplanes. So we have to find the rate of change of this side. Okay? Because as this is getting closer, this is still going away. So it could be decreasing or increasing depending on the plane's velocities. Okay. So what formula should we use?
Wait, what are we looking for?
The rate at C is changing, the distance. So we can do A squared plus B squared equals to C squared. I'll label this A and this B. What's the first step that we do?
Take derivative.
Yep. So what would we get?
2A dA dt.
Yep. This time it's with respect to time, because it's a related as well.
Plus 2B dt dt plus 2C dc dt. You can factor out the 2's and get rid of those. And you can plug in.
Yeah.
A is 4, 2A, dt is negative 250. Plus B is 3, 2B is 300. And then C is 5.
Yep. See, that wasn't that bad at all. It was just, this was the main part, and then you guys knew. What? Yeah. We divide everything by 5. This would be
That negative 1,000 plus 900 is negative 100 by
negative 100. This would be 60.
B.
Well, the 300 would drop down to 60. So it'd be negative 400. I did it wrong.
What is it?
No, it'd be.
That's a negative
That's
10.
negative 1,000.
And then
Why are you
Plus-
saying 1,000? Oh, you've already multiplied to it. Okay. So I'm just dividing those by 5. So negative 40 plus 60 equals 20.
All right.
You are multiplied them and then divided by.
Yeah. Multiply.
That should be a negative 20 though, shouldn't it?
Yeah. Because you'd have a negative 1,000 plus positive 900.
Yeah.
You get negative 100 divided by 5. Positive 5.
Yeah. This would be, and what did I do wrong? What's that? Oh, this would be at 50. negative 50. That's where I made a mistake. Negative 200 plus 180 equals negative 1. And what's wrong with this?
Should be miles per hour.
You need that unit there. And what does that tell us?
That the speed is 20 miles per hour, but
If the change between the planes is negative 20.
Yes.
well, yeah,
Getting closer.
Yeah, that means the 2 planes are getting closer because it change in the area is becoming smaller. If even though B is traveling faster, that's not fast enough for it to make the change be positive. That wasn't that bad. I can do a sign chart one, but with max and min. But you guys are good with those. Okay. The rest of the stuff is just the new stuff.
So does Dr. Tyler teach 1 through 4 in calculus?
This semester he's not teaching differentials. Last year he was when I was taking Calc 1.
Did you see him? Was it last year that he had the heart attack or whatever? How long ago was that?
I don't know. It was before,
You heard about it?
but he's been teaching here for a while. He enjoys it. I mean, yes, people. He's been at speed school since, like, he's been in Louisville, like, I think all of his life. Like, he went to speed school here, got his PhD, and I think he has a PhD in math as well. And just has been teaching here the whole time. But, like, if you ask older people who, like, I asked one of my dad's friends who works at GE in Louisville, I asked him, who did you have for calc? And he said Tyler. Like, I didn't even need to mention Tyler's name. You remembered Tyler.
Yeah. I guess my uncle had Tyler too.
Yeah.
He was practice 75. Yeah, he would have to have Tyler.
Yeah.
Back then, they had to use a slide rule, like the abacus.
Yeah.
But they didn't have calculators, but they still had to use that, so it kind of makes me mad. We don't get to use anything.
Oh, our calculators can do way more. Yeah. So, f of x, let's just do a problem. Actually, before we do that, I'm going to go over change in f again. Like I went with you guys 2 weeks ago, but still good to see that. Because I think a lot of people might have forgotten to study that for their exam because it was just a small topic.
Wait, what's topic are you talking about?
Change in f. Did they study with you guys that? Or
Yeah.
did they test you guys on that?
Yeah, it's like change of f equals.
Yeah.
Got it already.
Is equal to f of x. Oh,
X.
so let's change in x minus f of change in x. F of x. That's how we find the change in f. And df is equal to f prime of x times dx. That's the same thing as that.
Well, they're like approximate, right? One
Yeah.
another.
Yeah, I'm saying that dx is changing x.
Oh, okay, yeah.
That one people normally just forget about.
I don't know. I focus so much on that. I'm like, I hope I makes it on easy.
Change in f is approximate to df. And then if you want relative change, like they could just ask, find relative change. You just need to know that relative change is change in f over f at x of o, or df at f of x of o. So this is relative change, and absolute change, or yeah, percent change is that multiplied by 100 to get a percent. Do you guys know what these are called? They're called absolute change. So if they ask for absolute change, you need to find one of these or whichever they're asking for. Relative change, you divide them by f of x o. A lot of students don't read up on that, even though it's an objective, so they just lose that question. Like that's like 5 or 6 points.
Who's 7?
7?
So,
Yeah. See,
How did you actually memorize it?
it's 7 points easy that people just miss one. This is a really easy topic. You just need to remember it, and then you
yeah,
just
that's literally the question. Yeah, honest.
I mean they
You got it wrong.
How do you put anything?
yeah. Like they just ask you find f of x, find f of xo, or find the derivative of x, and you just plug and chug.
Yeah.
But people miss it. And then error is would be df over x. Or dA over A, something like that we did before. But you guys now should be used to how the tests are. Like they don't ask a silly question, like they ask like a full-blown question with all the parts that, so you're essentially being tested on everything at once. Are you guys good with graphing? Like sketch and labeling a triangle when it's,
Well, what was weird about yesterday's is they gave you 2 different quadrants it could be, and then like so you had to still
Decide.
figure it out.
yeah, like I could show you guys the problem with that.
I think I still got it right.
Okay, so this is one of the old exams that we covered in SI, but they did cover something like that where it could be in either. So I'll just go over that quickly. So if we have cosine of theta equal to negative 5 fourths, and we wanted between negative 3 pi half and negative 5. Okay, so the first step is just drawing this. This is cosine of theta, right? Or not cosine, cosecant.
1 over sine.
Yeah, 1 over sine. Hypotenuse can never be negative, okay? Since it's 1 over sine, we know negative 5 fourths, that the top is what?
The hypotenuse.
Yeah, the top is the hypotenuse, the 4 is the
Opposite.
opposite.
So it's really a negative 4 over
Yeah, so you have to remember that. And if the opposite is a -4, is it going to be up or down?
Down.
Down. So it's going to be either in 3 or 4 quadrants. Okay? We know that now. This tells us that it has to be -3 pi over 2 to -pi over 2. So we have to go sort of backwards. If we go backwards, this is -pi over 2. -3 pi over 2 would be this. Should be right.
Wait, wouldn't it be opposite?
Yeah, it should.
-3 pi over 2 would be at the top. I mean, negative pi over 2. Yeah,
Yeah, sorry. This would be -pi over 2. This would be -3.
Wouldn't that be -3 pi over 2?
Yeah. That makes sense. Yeah. There you go. -pi over 2 to -3 pi over 2. But
So we know it has to be in the third quadrant, right?
we know it was on below the y-axis or the x-axis. Now we know it has to be to the left of the y-axis. So it has to be on this part. Like, that's how it works. And if we were to draw a triangle, we know that this has to be a 4. We can mark it a -4. This is a 5. Since it's on the left side of the y-axis, this is a -3. So tangent of theta is what? 3 fourths. We have to label theta though. Theta is going always from the positive x-axis to the thing.
Oh, yeah, that's not true.
Yeah.
I forgot to mark theta.
Theta is +4/3. And then in this one, secant of theta is equal to -4/3. Theta is between 0 and 5. So if we were to draw it, okay, secant is what? 1 over cosine. So -4/3. This is the hypotenuse. This is the side. We'll call it adjacent. Yeah. We know that adjacent now has to be negative, right? Because the hypotenuse can never be negative. If the adjacent is negative, we know that it has to be on this side. Yeah? The x value has to be a -3. But we don't know up or bottom. We know it has to be between 0 to pi. This is 0, this is pi, so we know it has to be on the top. So it goes like that. That's theta. The hypotenuse we found is 4. So it's the square root of 4 squared minus -3 squared, which is 7. Square root of 7. So then they ask for cotangent. That's -3 over square root of 7. Cotangent is again adjacent over opposite. But you sort of need to write all of this. This is not necessary, whereas they have adjacent, but you need to show the angle, all the sides on here.
I just put theta inside the triangle by accident.
Yeah, you need to show it on the outside.
Yeah.
Because the conventional way is theta is always from the positive x-axis going somewhere. So that's how you figure those out. So basically knowing which quadrant you need this and which side is negative, then you can pinpoint it to which one. Otherwise, yeah, you can get stuck. Do they have any limit problems?
It did.
Yeah. It's just like,
Those with sine of x over x or something like that?
it's like, yeah, to use those ones to get to it. I don't remember.
Yeah, those aren't. Well, if you know your true identities, those should not be tough.
I did well on those.
So you said there was a problem with like that form A is equal to, sorry, y is equal to a sine of 2 pi over b.
Oh yeah, there was
Did you guys get that? Okay.
the a sine 2 pi over b
Times x minus c.
c plus d.
Yeah, that one you need to remember that correct formula and show that.
That one's not going to be on the next exam, is it?
It could be. It probably won't be because it's not a tough concept. They'll focus more on just max and mins now. But since you guys' exams are cumulative, it could be.
I hate that though.
Yeah. We didn't have that, but we had those practice time reviews that you guys have.
Yeah.
We had those as quizzes every Tuesday. And yeah, those are really tough.
And they actually like graded those?
Yeah. And yeah, we only had one chance to do them.
That's good.
Well, were you more prepared for test afterwards?
It depends on the people. Like I reviewed so that I could do well on the quizzes. A lot of people tried to cheat. So that's why they took them away because too many people were cheating with them. But they were a good review. And then my tests were on Thursdays, which like I really liked because then you have nothing Friday.
Yeah.
But you guys have tests on Tuesdays. Or
Which you have more time to study.
that's true.
On Tuesday?
Yeah,
Like over the break.
Yeah. I'd rather not study on the weekend though, but that's just me.
Yeah, like everyone studied on Wednesday nights.
Yeah.
Like everyone. And you guys now have to study on Monday nights, I guess. Mainly everyone does that.
I just push everything off until like Tuesday,
Yeah.
so I can just study on calculus on Monday.
That's how it works. Like no engineer cared about any other subject or anything except getting past Thursday morning.
Oh, yeah. I always get here like at 6, maybe. No, not 6, like 7:15ish, so I can like look over the material before the test.
That's true.
Do you commute?
Do what?
Do you commute here?
Yeah, both of us.
Oh, you both commute?
Yeah, I just wake up really early.
That's tough.
Honestly, though, it pays off. I think because it's then like fresh in your head.
I commuted over the summer.
Do you live here now, or?
My parents always, we live in Louisville, but I wanted to stay on campus, which does cost money.
Yeah, like almost doubles in tuition too.
What are the 3 steps of showing that something is continuous?
We met from the left.
Wait, what's the first one? That's the second step. No, you have to show that the function
of that point.
Yeah. So just afterwards. The second is the limit.
From the left and from the right.
Yeah. So it's the negative or the positive. Third one isn't really a step. Third one is just
Just make sure they equal each other.
yeah. So f of x is equal to the limit. As x approaches.
That's for continuity.
Yeah. Those are important because to find the max or mins, you need it to be continuous. And then, what are the 3 things that you check for max and mins?
F of x equals 0.
F prime of x.
Say f prime of x. And then f prime of x is undefined.
Yep.
And
But
the end,
and then what?
the endpoints.
With undefined, it's whenever you basically have a fraction. That's when a denominator. That's when you'll have undefined. If you don't, you just say no points. Move on. The test for max and mins. Now, in this exam, they will tell you to use the second derivative test instead of just leaving it up to you. Because last exam, you could use the first derivative, check both sides. So second derivative test, you have concavity, which you look for. So if the second derivative is a negative number, what is it?
Concave down.
Well, what does that mean?
What does it mean?
Yeah. Is that a local max or a min?
Local max.
It's on top. What if it's positive?
Concave up,
Concave up. That's a min. And what if I have an endpoint where the second derivative is positive?
Local max. Maybe. Right.
Or you can't do it at endpoints.
Can't.
Nope, that was a trick question. You can't use the second derivative test at endpoints. You have to remember that. No,
Wait, we did the first
So what would you do
derivative.
you do the first derivative and check. So for the left endpoint, it's on this side or something. You do the first derivative from the right side.
Right. The right to the left.
But you can't do the second derivative test because there is nothing that goes up and down.
But can you say that like the integral between the endpoint and the x point, that's concave up and down?
If you test that point,
Yeah.
like if they give you an endpoint of -8, right?
Yeah.
You can't put -8 into the second derivative. Okay? If you were to test it with a -7.9 and then say, all right, the concave is down, you could do that. But then what if there's a teeny tiny bit difference that you can't see? Yeah. You have to be exact. So yeah, -7.9 is not where the domain ends, so the answer would likely be the same. But still, for accuracy, you can't do that. For inflection points, there are two things that you test.
It has to have a unique tangent line, and the concavity will change.
So yeah. How do you get the possibilities?
Second derivative equals 0,
Yep.
and second derivative equals 25. There it is.
Yep. And once you get those possibilities, then you still need to show us a unique slope. So that has to equal a number.
How is that problem?
Is it F prime? Yeah, the slope has to be. There we go. So you need a unique slope. It can't be infinity or negative infinity.
Wait, it can't be a negative number?
It can't be infinity or negative infinity. Yeah. It has to be a specific slope. And then you justify that by seeing if it's concave up or down by a second derivative test. And then sketching shouldn't be that tough. Like, it crosses, like, that's an inflection point or something. There's a max there, there's a min here. So it goes like that. And this, like, you would have found out this is concave down, this is concave up.
In the videos, they talked about like horizontal and vertical tangent lines. I know how you find out horizontal, but how do you find out vertical?
With infinity.
With infinity?
Like, yeah. They haven't covered that in class or something. But you'll go into asymptotes, vertical asymptotes and stuff. And so it's like plus or minus infinity. Because the slope like right here is undefined.
Yeah.
in high school calculus, we did asymptotes way before we did this kind of stuff.
So this stuff you use the derivatives and stuff. Rather than in high school, you guys probably just had a function with 2 factors on top. Yeah, and whichever. Like so it's n squared over n squared. If there's a 5 here or something, horizontal 5, or something like that. That's pretty much it, guys. And then, yeah, it's a lot of it is just custom stuff in this unit. And then asymptotes, oblique asymptotes, which we will cover in the practice exam session. So not too bad, just remembering the old stuff. Did you guys have a proof or something?
Oh, what?
A proof for like the product rule or stuff like
No,
that?
we
It's like graph.
yeah, we had a derivation.
Not in it.
Yeah.
It's not